Welcome to a new test and teardown video. This time it's a switch mode power supply and AC to DC converter. Look at the size of this thing. I mean, it's like 10 kilos or something like that. Really big and mean. I actually wrote down the size here, so it's 26 centimeters wide, 31 centimeters deep, and 18 centimeters high. Look at that. It's massive. So I think this is the Siemens product number, and this will be a SUP product number, maybe. ACW, yeah. I don't know exactly. But it says output voltage is 56 volts and maximum 5 amps. So this is only 280 watts for this huge box. But it also says 48 here. So what I think this is actually, this is just my guess because I can't really Google this. It doesn't really show exactly what it is, but I think this is a 48 volts lead acid battery charger. And I think they reveal it by this 56 volts top-up voltage. So it's probably going to stop there. So we got some indications here. Overcurrent or operation. There's nothing in this hole. And this is the under voltage for mains. And then we got some DC output. Oh, really, look at that. Only 5 amps, and is it one of these? No, it's not. So you need to screw here and put in some really, see, I can almost, okay, but this looks like 30 amps or something, but really only 5. Got some fuses for our mains. Yeah, neutral fuses, wow. Caution, double pole, neutral fuses. Ooh. How about we just plug it in and see if it blows the fuses here, right? I think that could be fun. So this is going to be fun. I think we are ready to blow this up. Hopefully nothing bad's gonna happen. We'll just give it 223 volts. And nothing happens. Ew! It consumes only 2.7 volts and there's no LED. That is weird because I got no output, but I can see current, and it actually went to 20 watts and then back to 0. Really? And I think this is because this is a battery charger, so we need to give it some battery voltage before it's gonna wake up. Don't you guys think this is exactly what's happening, right? So what if I put in some DC? Yep. Turn this input off. Okay, so here's what we're gonna try. See what happens. I got 48 volts via a diode because I don't want this thing to blow up my power supply if something bad happens. But my DC load can handle 150 volts. So I think that's going to be alright. So my DC load is now also connected here, and my voltmeter here at the same time. So that means now it will probably think there's a battery connected, and if it tries to raise the voltage, it's going to see my DC load. And right now I put the DC load for like 0.46 amps. Oops. How about we just crank this on? So now the DC load is loading the power supply via this diode, and this is how it is, right? So let's power it up and see what happens. Still a lot of absolutely nothing. No LEDs, no indicators. Damn it, this shit is not working. Anyway. That means we need to open it and see what is inside anyway. We are now inside this case, and it's 99% air, but I'm already really happy because look at this heatsink. No matter what happens, this is a cool score. This one is absolutely nice. Look at the thickness. So this is 10mm material and mounting, and wow, great score. No matter what happens to this power supply. And what I did is, fuse is okay. This is the output filter, so more filter, output current sense, output capacitors. So this is the output inductor, rectifier and snubbers. And since you got two of them, this is of course push-pull, right? And then you got the main switch mode transformator, and this is driven by a half bridge push-pull. So we got those two capacitor, and then it's pulling this system. See, there's another fuse on the high voltage side to the half bridge, and that fuse is also okay. And then there's a little nasty fuse down here. I didn't check that one because it's difficult. But what do you know? Look at that. In the middle of the picture right now, you see two diodes. One of them desoldered itself and kind of puked out some material. So that diode is blown up. But why is this blown up? This is probably in the flyback. So this is probably a flyback system, either with, no, not that one, but probably here we got the flyback system for this one. So this is the auxiliary supply. So the current consumption that we see is actually charging this main capacitor, and then discharge resistors for that one. Or this is probably an inductor. Yeah, so this is the power factor. Alright, so we've got an active power factor. That will be those components, and this explains the idle power consumption. So this is probably working, and then we are missing auxiliary supply, so nothing starts up, and this way LEDs are not running or are working the way they should. So this is where we need to look. It is that easy. So I think I'm going to take out the entire PCB and see if this is right. But anyway, mains input, fuses, both sides, really nicely done. Good solid input filter with double common mode chokes, very good power up, inrush protection, NCC resistor. This is also a very good idea. And then we go to the rectifier, a bridge rectifier, and then we're going to the active power factor. Look at the isolation to chassis. Really? This is crazy. It is like 3mm thick. So they really didn't want any spark over to chassis. And this heatsink is definitely connected to chassis. I've been looking a little bit more on this, and I've been removing all the screws and all the cables, desoldered here. So I guess I'll be able to lift out this PCB, and then we'll be able to look in more detail what is going on. And I'm still a little bit afraid because I did power this thing up, so there could potentially be a lot of voltage and a lot of energy stored in some of those caps. So just be careful with stuff like this. And look, it's full of spiders, but they're all dead. Whoa, this is really... look at that. All sorts of bugs. Funny little thingies. All those spiders, but they're all dead. Ooh, there's some big ones. Ooh, what have we got here? That is the bottom side, and that is... Aha, so that disconnected itself, and that is probably why it's not working. Is it that simple? I mean, seriously, you gotta see this. Okay, so this down here, this one in the middle of the picture, see a round fuse. This is for all the auxiliary stuff, and that is that one. That is open, okay? And this is of course connected to some of all this stuff in this area where this blown up diode is. The funny thing is this diode actually measures all right. So we got half a volt in one way and nothing in the other way, and it is actually still connected to that track and to that track. So it is still connected. And so there's something that is overloading this power supply that is causing the problem. And just in general, when I look at this power supply, there's just something that tells me this is bad. We see also some muds and some components flying up in the air, but look at that one. It's not connected, and it's not even soldered to anything. See? So the point is, see? Why is this? I really don't want to continue playing with this power supply. It is just cursed. They're not done playing with this design. This is a prototype that went wrong and blew up. It was overloaded. It was just put in the trash, and then somebody took it and gave it to me. So I'm so sorry, guys. I'm not going to fuck around with this because I know exactly what's going to happen, and that is I'm going to get some stuff up in my face, or I'm gonna burn down the house, or I'm gonna get, you know, a big electric shock and shit, or at least just waste a lot of time, because this is just old crap. But I really want this heatsink. That is what I want. I don't want to scoop around with this anymore. Anyway, this is just way too big for 200 watts, 48 volts. I can just go and grab a little Meanwell that is like a factor of 10 smaller, and I can get them for free anywhere. So there's really no motivation at all for this over-complex, over-complicated, way too big thing. The only thing that I really love is the heatsink, and of course it's made super silent because of that super big heatsink. There is no fan, and so you need an oversized heatsink to keep everything cold. And look around all the fats and stuff. There's no brown marks. There is no black dots on any components. Nice. Okay, let's just have it a last piece of fun and enjoyment. I replaced the fuse with one hanging like this. I didn't have the 315 milliamps like this. Alright, let's just see what happens, right? And then I crank up the mains voltage real nice and slow, and then we see if it just blows up at the first few volts, okay? I think what is going to happen is it's going to power up the power factor, and that cranks up with a big smack, and then this fuse is probably just gonna blow. Okay, 120 volts. So that's 200 volts, still nothing. Let's just turn it off. Boring. Ugh. But the fuse is gone. Oh, that was boring. But anyway, there's a complete short in this system, and I can't be bothered. Just sorry to say, it's really not worth any more seconds of my life. I want to go to bed, and I want to sleep long, and I want to be happy. See ya.